Big Bang advocates are scrambling to make sense of what the James Webb has discovered.
Yes, they are, because what they're finding is completely different from what was expected to be seen out at such distant edges of the universe.
Can you tell us about some of those discoveries and why they weren't expecting them?
Absolutely. When you look at such things as what James Webb is finding, it's simply God declaring his glory to us. He's showing us that he is an all-powerful, all-knowing, almighty, eternal creator God. And when we look at the universe around us, that is the conclusion we draw.
The James Webb Space Telescope has revealed massive, highly structured galaxies on the outer edges of our universe. The problem is they're not supposed to be there. Mark, you've worked in the aerospace industry for over 30 years and you speak internationally about this question of origins. Why shouldn't those discoveries be there?
Well, Jess, they shouldn't be there because they weren't expected to be there. They don't comply with the predictions of the standard model of the Big Bang. And that model is the accepted model these days in our secular society that basically attempts to explain the existence of the universe without God, without a creator. But the model has turned up wanting yet again.
Can you tell us a bit more about what this model, the Big Bang, teaches us?
Sure. The idea is that there's this infinitely small, infinitely hot point, a singularity that occurred 13.8 billion years ago. It rapidly expanded, and as it did so, elements like hydrogen and helium formed. They finally condensed down and formed stars, which consumed all their thermonuclear fuel, and some exploded and produced heavier elements. And then we ended up with swirling clouds of dust and gas that then became stars with planets orbiting them like our planet. Then the Big Bang theory suggests that in time, all of that energy will dissipate and the universe will experience what we could call a heat death, where everything becomes uniformly cold and dead. That's billions of years apparently into the future. So in a nutshell, that's the kind of secular model of what the Big Bang is. So the Big Bang attempts to use natural processes to try and explain how the universe came to be. The problem is that actually involves invoking a number of miracles, and we had another video in this series called 5 Atheist Miracles that I encourage our viewers to have a look at that explains some of those.
So did the universe actually have a beginning?
Well, the Big Bang theorists believe that it did, but herein lies an interesting problem for the secularists, because if you ask them, did the universe have a beginning, and they say yes, then they actually violate the first law of thermodynamics, which says that matter can be neither created nor destroyed. So to go from nothing to absolutely everything requires the creation of all of this energy and this singularity, as it was called. So you have no mechanism for that to happen. That, in fact, is the first of the atheist miracles that they have to believe. If, when asked that question, did the universe have a beginning, the answer is, well, no, as some believe, well, then you violate the second law of thermodynamics, which says that in every naturally occurring process, the level of disorder or entropy increases. Or another way of saying it is that the energy available to do work decreases. And that's the forward-looking picture, if you like, of the Big Bang. It finally fades away into a heat death. So the secularist has a dilemma. If the universe had a beginning, he violates the first law. If it did not have a beginning, he violates the second law.
He sounds caught.
Well, yes, it's between a rock and a hard place. You're quite right. The only way you can resolve that dilemma actually is by having a supernatural, all-powerful creator God who brings the space-time matter universe into being, separate from himself. And then and only then do you have a plausible explanation for how the universe actually had a beginning, which is what the first verse in the Bible says, of course. In the beginning, God created the heavens and the earth.
Okay, so could God have started the Big Bang?
Well, I don't think so, because the Big Bang is totally inconsistent with what God tells us that he did in the creation week, those first 6 days of creative activity. where he was speaking things into being which did not previously exist. Now, people might say, hey, hang on, that's a miracle. Yes, it's true, it is a miracle, but the Christian has a miracle worker, and that is our Creator God. And so that's perfectly logical. To have a miracle without a miracle worker, well, that's magic. So the Big Bang has, for instance, that light came before the earth. But in the Genesis account, it says God created the earth, and then he said, let there be light. And there was light.
Okay, so it's in conflict with...
The sequence is completely out. It also says that, the Bible says that God created the sun, moon and the stars on the fourth day of the creation week, which of course was after the creation of the earth. But in the Big Bang, it's very much the other way around. The earth doesn't appear for some billions of years after that initial singularity. So I don't think there's any way one can reasonably harmonise the Big Bang model with what the Bible plainly teaches us.
Because you're compromising what the Bible actually says,
Yes,
how God did it.
That's right. And importantly, when you do compromise like that, you introduce millions and millions of years of whatever's happening before Adam and Eve are even created. And the Bible says they came on the sixth day of creation. Now, God is powerful and purposeful, and when he speaks, his word goes out and accomplishes exactly what he intended. So his purpose in creating the universe was to make a home for man, who has been made in his image, the Bible tells us. So it makes no sense at all to have this universe sort of randomly pottering along for billions of years before God finally gets around to creating mankind in his image. So it actually cuts across any sense of God being purposeful. So if the Big Bang is true, then the Bible is not. But if the Bible is true, then the Big Bang is not.
So is there any observational support for the Big Bang?
Well, the Big Bang came about through astronomers making observations, but with a perspective, a philosophical bias, if you like, that they were looking for mechanisms of explanation which excluded God. So back in the early 1900s, I think it was 1916 or thereabouts, Vesto Slipher discovered that galaxies had their spectra shifted towards the red end of the spectrum. Now, that doesn't mean they were red, it just means that the spectra was slightly shifted that way. Now, he interpreted that as possibly due to recession, like Doppler shift. In 1929, Edwin Hubble observed that the further away galaxies were, the more they were redshifted. So he interpreted that as meaning they were receding from us faster and faster. So you get this picture of an expanding universe. Now, interestingly, Hubble didn't like what he was seeing, because in every direction that he looked, he saw the same phenomenon, these receding galaxies, which implied that the Earth was somehow or other in a favoured or special location, at or near the centre. And he actually said this is an unwelcome supposition and must be opposed at all costs, which is, I guess, revealing of his philosophical position. Because, of course, if the Earth is special, then that suggests that maybe there's a creator out there and we're in a special place. And if there's a creator, well, maybe we might be called to account to that creator. So he simply didn't like what he was finding. And so he pushed back on that and he said, I believe that the universe will look the same no matter where you are within the universe on a large enough scale. Or another way of saying it is, the Earth is not special and everyone must see the universe alike. Now, this has a name now. It's called the cosmological principle. But I think the simplest way to sum it up is to say they believe the Earth is not special.
Okay. Does the Big Bang correctly explain then some of the observations that we make, the things we see in the universe today?
Well, we're told that it does, but there are many, many things, in fact, where the Big Bang fails to explain the observations. And so what happens is, because there's a philosophical commitment to a naturalistic explanation, various sort of rescue hypotheses get proposed to try and patch up the bits where the Big Bang doesn't really quite work. And we'll talk about some of those in a little while. But I don't think that it really adequately describes what we observe at all. In fact, most recently, as you opened, the findings of the James Webb Space Telescope were a complete shock to the Big Bang community. It was not what they were expecting to see.
Can you tell us about some of those discoveries and why they weren't expecting them?
Absolutely. So the James Webb Space Telescope is it's a $10 billion telescope, an extraordinary project. Brilliant engineering, I might add. It's designed to work more in the infrared parts of the spectrum, which enables it to see beyond the visible part of the electromagnetic spectrum and to see galaxies that are so shifted in spectra that they would be very, very remote. In fact, in the Big Bang model, that would represent galaxies formed at the earliest stages of the history of the universe. And it's a very clever design. It actually orbits the sun, not the Earth, but in the same time that it takes the Earth to orbit. And it sits at a place called the Lagrange point, number 2, and it's a gravitationally stable location. It actually orbits that location so that the Earth is always between it and the sun, so it doesn't ever get blinded by the light of the sun. And it points these very sensitive infrared instruments at the remotest parts of the universe. So very early in the Big Bang, gravity would not have had, or should not have had, enough time to draw all of this material that had formed from the initial energy and that singularity that commenced it into large, highly structured galaxies like our Milky Way. So they expected to find indistinct, fairly small, fuzzy blobs of stars, not high structure with spiral arms and central bars and all this sort of thing. But to their astonishment, they found massive, highly structured galaxies, and even fairly recently reported a supermassive black hole that is 10 times the size of the black hole at the centre of our Milky Way galaxy.
Can you explain what a black hole is, Mark? Because I've heard that question many times before. Do they even exist? What are they?
Well, a black hole is where there is so much matter within this very small region that the gravitational field around it is so intense that not even light can escape it. So surrounding every black hole is what's called an event horizon, and anything that passes through that event horizon disappears into the black hole and cannot be seen. Now, various complicated physics tells us that they radiate and so on, so they can be detected. Very real, quite amazing phenomena. But they involve the accretion of a massive amount of mass. So you can't have a supermassive black hole at the outer edges of the universe where there hasn't been enough time for gravity to aggregate all of that material. Consequently, it flies directly in the face of the Big Bang model. You also haven't got enough time for those highly structured elliptical galaxies to form. So it really was quite sensational. One astronomer reported that he lay awake at night wondering if all he'd been doing for all these years was wrong.
Wow.
Pretty good question. Maybe it is. But the point is, you see, that they begin with a fundamental assumption, and that is that there's no God, and they try to use naturalistic processes to explain the universe. And it really doesn't work well.
Yeah, it sounds like with each discovery that the James Webb is making, there's not enough time for that to be present or the way that it is.
Yes, that's right.
In light of these findings, are secular astronomers abandoning this idea of the Big Bang?
Yes and no. The Big Bang is a naturalistic model, and it's got a lot of investment in it. People have got their names attached to various parts of the model that they've developed. They have professorships and they're famous, and so it's pretty hard to let go of that. But there are other secular astronomers and cosmologists who don't subscribe to the Big Bang because they see the flaws in it and they see how it doesn't really very adequately describe the observations that are being made. So there are other models around. One that was in vogue back in around the middle of last century was called the steady state theory. And that kind of went out of fashion when the Big Bang rose to ascendancy with the discovery of the cosmic microwave background radiation. And we'll talk a bit about that in a few moments. But interestingly, the steady state is making a bit of a comeback now, partly because of the findings of James Webb. And what people need, you see, is a lot more time for the age of the universe. So they're thinking, well, maybe our idea of the 13.8 billion years is just too short, because now we're seeing the edges of the universe with mature galaxies. Perhaps it's been around a lot longer. Oh. Now, this happens to play havoc with other parts of the model, so it's highly contentious. So there are various varieties of it, and it really has opened the whole debate wide open in cosmological circles now.
Mm. Can you give us some examples of the big problems that this theory's failing to address and answer?
Well, yes. Apart from the findings of James Webb, there are a lot of issues that the Big Bang simply doesn't answer. And one of them is called the Baryon asymmetry problem. And that's just a technical term, but what it means is basically this. In that initial Big Bang, it was a highly dense point of incredibly intense energy, which then started to cool as the universe expanded. And as it expanded, some of that energy was converted into matter, initially in the form of hydrogen and helium gas and so on. Now, when energy converts into matter, in every experiment we have ever conducted, and according to theory, you should produce equal amounts of matter and antimatter. Now, antimatter is where you might have, for instance, an electron, instead of being negatively charged, becomes positively charged. And protons have negative charges. So they're the mirror image, if you like, of matter.
Is that how you'd explain antimatter? Because I was going to say, what's antimatter?
That's right. So it's like a mirror image.
Okay.
So, but if matter and antimatter come in contact together, they instantly annihilate with a release of energy as well. So if this energy had converted itself into matter, where's all the antimatter? Because all we observe in the universe is matter. And so that's a major problem. As I said, it's called the Baryon asymmetry. Baryon are the component parts, if you like, of an atom. And there is no satisfactory explanation for that particular issue. That's just one of the problems that the Big Bang that fails to address adequately.
Because we should be able to observe the antimatter.
We should, if the Big Bang model is true.
Okay.
Then we should see approximately equal amounts of matter and antimatter.
Okay. Another one?
Well, another one is that as the hydrogen and helium, matter, not antimatter, started to condense into stars, then the initial stars should have been of very light gases, hydrogen, helium predominantly. And they should have been the majority, and then over time they would burn all their fuel, because when they get very, very large, nuclear fusion starts to take place. This ignites the star, it radiates heat and light and so on. And then when it burns out, some of them will collapse and become supernovas. And it's believed that that's the mechanism by which heavier elements are produced. Now, of course, in our world, we have lots of heavy elements, things like carbon, oxygen, iron, and so on, and way more than just hydrogen, helium, of course. And the problem is that these initial stars, which are called population 3 stars, should predominate in the outer edges of the universe. After all, they were supposed to be the first ones that formed. But there have been no population 3 stars observed. So the observations don't stack up with a very clear prediction from the Big Bang. So it's failed again. So the problem of the missing population 3 stars is one of yet another of the unanswered challenges for the Big Bang. And the third problem is called the horizon problem. One of the things that swung opinion towards the Big Bang was the discovery of what's called the cosmic microwave background radiation. And it was predicted, and then it was discovered by some scientists back in the early parts of the 1900s. And essentially what it is like an afterglow, and it was believed to be the afterglow of that initial Big Bang.
Yes.
And it was expected that it would have very hot regions and cold regions, and that the hot regions, for instance, would be like the fingerprints of what would subsequently become galaxies and so on. When it was observed, it seemed to be very uniform, very little variation in the temperature, because any body that radiates, it will radiate according to its temperature. So hotter bodies will radiate more energy than colder ones. So by observing the amount of radiation coming, we can make a measure of the temperature. And it was found that the temperature distribution of the background radiation was incredibly uniform, like flat to 1 part in 100,000. Now, to think about that, that's like trying to get a surface dead flat for 100 metres and not varying by more than 1 millimetre.
Okay.
Now, that's very uniform, right? And that was extraordinary. That was not a prediction of the Big Bang. That came as a shock. And so the problem is this: you've got these hot regions and cold regions in that initial background radiation. How did the hot regions exchange their heat with the cold regions to make it all so flat and uniform? Because there hasn't been enough time for that radiation to get from one side of the universe to the other side. And that's what's called the horizon problem.
And have they tried to answer it?
Oh, of course. And there was a solution put forward in the 1990s by a guy called Alan Guth, who supposed that there was an event called inflation that occurred an extraordinarily short time after the initial expansion of this singularity, lasted for an unthinkably short period, and during which the volume of the universe expanded massively by many, many orders of magnitude. Now, his model has it that that would have evened out all of those temperature variations. But the problem is there's no mechanism in physics that would start such a process, no mechanism for it to end. That's called the graceful exit problem. And during this inflationary period, you have special physics happening. So, if you like, matter repels matter instead of attracting it, and weird stuff happens. Stuff which is not observed in the laboratory.
Sounds like another miracle.
Well, yes, it's pretty close to that. So, if you like, it's a what you could call a just so story. Now, the thing with developing these ideas and stories is that they may sound plausible, but plausibility doesn't equate to truth. So just because a scientist can tell a vaguely plausible story doesn't mean that the problem has been solved by any means. In fact, I would argue that the whole concept of inflation is actually not plausible at all. It's quite contrary to any observable physics that we do.
Mm. So scientifically, it sounds like there are a lot of quote, research problems that falsify the Big Bang.
Well, yes, and these things are not good science in the sense that the core issue is really not being confronted. Once again, it's because of a philosophical commitment to the idea that we must explain everything in natural terms. And that sounds reasonable if you're involved in the sciences. But if you think about it, if you limit yourself to only naturalistic explanations for things, you are excluding right at the outset and arbitrarily any consideration of the supernatural. So if you exclude the supernatural from consideration, that's the same as saying there is no God, which means that really it's just signing up to atheism. So the secular scientist has a commitment to an atheistic worldview, expresses it in the way he interprets the evidence that he observes, and that fundamentally is what we see in the Big Bang model. That's its root, if you like, its origin.
Yep. Does the belief then in this supernatural creator, God, in your opinion, does that line up with what James Webb is revealing to us? Do they make sense together?
Well, I think if we start with what the Bible says, which shows us that God is our creator, that he spoke the universe into being in just 6 ordinary length days, and that he created the sun, moon and stars separately, but after he'd created the earth, I think that whole unfolding of God's creative activity helps us to understand the observations much more effectively than the atheistic models do, the secular models. Because when you look at such things as what James Webb is finding, these incredibly detailed and intricate galaxies at the outer edges of the cosmos, it's simply God declaring his glory to us. And one of the Psalms, Psalm 19 it is, begins by saying, "The heavens declare the glory of God." And I believe indeed they do, just exactly that. So in a sense, it's a bit like God is showing off, if you will. He's showing us that he is an all-powerful, all-knowing, almighty, eternal creator God. And when we look at the universe around us, that is the conclusion we draw. Mm. So I think our response to that should be not one of, I suppose, arrogance and saying, well, God, we figured out how you made the universe and you did it with this big bang. Rather, we should come humbly before him in the light of the evidence that he's given us and acknowledge that he is indeed the creator God.
Mm. So if someone turned around and said to you, oh, well, that sounds like a bit of a cop-out, Mark, because, you're just kind of saying God did it, and so that makes sense of what James Webb is discovering, what would you say?
Well, I don't think it's a cop-out. I think it's acknowledging the reality of what we see. Because, you see, all the observations are like signposts. They point towards the truth of the scriptures. Mm. Now, science doesn't prove the Bible. In fact, you can't do that, because if you did, it would be like elevating science above the Bible. And that makes science the benchmark. It makes it the arbiter of truth. But it's the other way around. You see, you start with God's eyewitness testimony of what he actually did at the beginning, and we use that historical record as the means by which we interpret the evidence in the world around us. So rather than a cop-out, it's actually acknowledging the reality that the best description of the universe that we see around us and that we can measure and observe with brilliant instruments like James Webb is that there's a creator God out there.
Mm. Did creationists try to predict anything about what we'd see with James Webb?
Yes, indeed, we did. And on our website at creation.com, there is a paper that was actually released the day after James Webb was launched back in late 2021. And in it, I'll just read the passage. We said, the JWST, that's the James Webb Space Telescope, observations will further contradict and complicate evolutionary theories on the origin of the universe. And what we said would happen is exactly what's happened. They've now got massive problems to how to explain these huge, complex objects so close to the commencement, apparently, of the universe. Another leading astronomer, creationist astronomer, Jason Lisle, said this, I expect to see fully formed, that means fully designed, galaxies at unprecedented distances. And that's exactly what was found. And he published that well in advance of the launch of the James Webb. He went on to say, I don't expect to see evidence of genuine population 3 stars, those with no heavy elements at all. Since I reject the Big Bang as the cause of the 3 lightest elements, I have no reason to believe that the universe was not created with some of the heavy elements already in it. So his prediction has been precisely confirmed. Once again, no population 3 stars, heavy elements found right at the outer edges of the cosmos. So starting with the Bible, starting with God's account of what he did to create the universe, places the creationist astronomer and scientist in a far more powerful position when it comes to trying to predict what we will see in the universe. And I think the work of James Webb has just brought that to the fore like no other instrument. So just remember I quoted Psalm 19 earlier on, and let me read a little bit of it to you. The first 4 verses say this, the heavens declare the glory of God. And how true is that? The skies proclaim his handiwork. I don't know if you have ever stood outdoors at night on a moonless, cloudless night and looked up at the stars. Now, you couldn't do it in a city. You have to do this out in the country where there's not much light pollution. But the sight is absolutely breathtaking, truly the skies do proclaim God's handiwork. And it goes on and says, day after day they pour forth speech. Night after night they display knowledge. I think, wait a minute, the stars don't talk.
Speech, knowledge.
Right. But it goes on and says, they have no speech, there are no words, no sound is heard from them. Their voice goes out to all the earth, their words unto the ends of the world. So this is, if you like, silent speech. What the heavens are telling us clearly is that God is the creator, that he's all-powerful, he's all-knowing, he's declaring his glory and his might to us, and it is absolutely unmistakable. So King David, when he wrote those words, got it exactly right.
Thank you so much, Mark, for sharing that with us today. It's fascinating and so encouraging to see how the latest scientific discoveries are affirming what the Bible tells us about our world.
You're welcome, Jess. It's been a great pleasure.